if that really matters. Yeah, you have to do a control experiment with really good samples to it.
Yeah.
It's hard to decide because you do get an overall size reduction on the
The problem with the trap is this signal height, okay, is not just the number of ions, it's the stupid time factor. Okay? So the question is when this height's changing, are we changing the amount of 325 we're making, or are we just changing the 325 to something else? On a quad, that height, since it's a real ion measurement, you can see it go up or down. On ours, since we got 30,000 ions always, is it the fact that I converted to something different, or am I making less of it? And you can't tell with the trap. It's kind of one of the little screwy trap things. So do we want to go back to 250? And do you want to save 3 tune files and try to run them and see what happens? Do you want to save like a 290, a 250, and a 200?
Or the
capillary temperature, and do you want to try different tube lenses? And it's up to you how many samples you want to sit running for 3 hours. I don't care.
Yeah, those ones you can automate.
Or do you want to do like a 250 instead of 290, which I think is a bit? Why don't we try like 250 at 2 different tubes and a 200 file?
So 250 what?
Capillary temp.
2 different tube lenses.
Right. So why don't you try like a 140 or 150 and a 115 and see what effect that has on your phosphorylation. And then take one of those two blends and compare it with the same two blends at 200 degrees.
Do we have any preventative circuit?
Yes.
Give the system a test automated sequence.
Yeah.
So we're going to do an experiment looking at 2 blends having 2 different values and doing preventative circuit 188, counting the minutes. Because it changes the distribution of the 3s and the 1s. Or the 3s and the 4s. Plus 4s. We're not.
And you want to do the mobile phase. Do you want to put this all into like a little?
The problem with the mobile phase is that requires us to be here to change the.
Yeah.
Unless we go for. Yeah. They could go for D. Because you would have to change 2. We're only using 2. 3 will do that. Typically, we would like to run a DSA sensitivity test on our reverse phase tip.
Okay.
Make sure that everything's legit before the best 3 hours. Because those are 37 minutes to get a sense for a PSA. We do a 150 ml shot of PSA, so you should see about 1,000 ml signals. That's just amazing. And that's at 200 nanoliters per minute. Yeah, I think that's worthwhile. So we'll call this, just call this will be the normal one.
You got to stop tune to save. You just got to close, yeah, hit just stop, and now you should be able to save.
I'm just going to save this.
Tube.
So we're going to do some. We might want to do these experiments on. No. So yeah, we'll finish up now looking at this phosphorylation
Okay.
Are we set here?
Yeah, so let's end the angio and let's go to the phospho.
It's almost digital. You either have enough voltage or not. Your spray will drop out if the voltage is...
That one you want to make sure you're in the exact same conditions you are when you're going to elute.
Well, voltage, well, I can make, that's the thing, I don't know what the best optimal is for the voltage for detection of phosphopeptides. Would change
the voltage should, no, the voltage...
It's almost digital. If you don't have enough voltage, you don't, it drops out the spray.
What I notice is, and this is totally tip dependent, but there's a,
I wish you could stay longer. That'd be. You get paid big bucks. So every day you make is 4 days. Jesus. 4,000 miles. So how much per hour? It's not the long business.
It's $3.75 an hour. Is what thermal gets.
Yeah.
Okay. I get my 37 an hour no matter.
No university would ever pay for that, right? So it's got to be only, I would guess it would be only companies that would actually.
Well, you paid for it.
Oh, right, yeah.
It was actually, if you actually looked on your instrument, if you looked on your breakdown of costs, it's right there as the 12,000.
Can you remove it?
Nope, we don't allow you to.
Yeah, so I didn't know.
And some people actually pay, like, we had a guy who bought 3 weeks, he bought 2 extra weeks, you know.
But, really? They said
I mean, yeah. I mean, you paid for it in 4 years of, you know.
Typically 150 volts you get 1,000 to 1 on the iron trap of those. FT I think is like 400 to 1. It's hard to measure noise in an FT.
Because we remove all the noise. Yeah, it's kind of a neat...
The other experiment that would be interesting to run is with lower resolution. See how many phosphorylation sites we discover.
Okay, what we typically I see, now your voltage is going to be slightly different because I use the pico fritz, is like usually there's kind of an onset voltage to get the stupid driplet to go to a, so with the pico fritz it's around 2,000 volts, okay? But what I notice is I have a lot of noise when I'm at the onset voltage. And if I back my voltage off, my noise clears up, and then I kind of reach this, what I call it, the sustaining region, which is usually about 200 to 300 volts range.
You like to sit in the center of that?
Yeah, because when you're in the water part of the gradient, you need to be up here. When you're in the organic, okay, if you're serious about sensitivity, what I actually do is I break my gradient into 3 pieces. I step down the voltage. So usually this for me is like 1.8, 1.7, 1.5.
What are these numbers indicating?
kV.
Okay. kV? No, not.
Yeah.
18,000 volts? We're doing.
No, 1.8 kV, which is
I see
1800.
the decimal. Okay. Like, wow.